How inappropriate is it to call this planet Earth when it is quite clearly ocean? Wonders a scientist. True, 70% of our Earth is covered by oceans, and consequently 70% of our natural resources are available underwater. Humankind needs to harness this wealth while preserving the beauty, the splendor, the life forms and the natural ocean characteristics. From the shallow waters at the coast to the deep waters and tropical regions to the polar areas, the resources vary, and so do the technological challenges. While man was able to reach the moon, knows a lot about the surface of Mars, the ocean next to us is still left largely unexplored due to its vastness, tremendous forces that it creates, and the sheer fury that it churns up at times. In the southern part of India, there exists an institute called the National Institute of Ocean Technology at Pallikaranai in Chennai, which has taken up this challenge of developing suitable technologies for harnessing the ocean wealth in an environmentally friendly manner. The Department of Ocean Development, now the Ministry of Earth Sciences, established the National Institute of Ocean Technology in November 1993 for developing and demonstrating technologies to promote underwater applications consistent with a nation-building exercise in marine infrastructure. Some of the programs NIOT effectively implemented are coastal engineering, desalination, marine biotechnology, ocean observation systems. Deep sea technology, science and technology of gas hydrates, ocean electronics, marine sensors, ocean acoustics, and vessel management. Energy and fresh water from the sea. Desalination. 97% of the water on Earth is salt water, leaving only 3% of fresh water, of which about 2/3 is frozen in glaciers and polar ice caps. The world's supply of fresh water, though a renewable resource, is steadily decreasing. Desalination of seawater holds the answer to it. NIOT has been working on desalination using the ocean thermal gradient. The surface seawater at about 28 to 30 degrees Celsius is sent to a low-pressure flash chamber where it instantaneously evaporates under vacuum. The generated vapor is then sent to a condenser where it condenses to water using colder deep sea water at about 12 to 13 degrees Celsius. NIOT has successfully commissioned the Low Temperature Thermal Desalination Plant LTTD at Kavaratti, which is supplying drinking water with a capacity of 0.1 million litres per day to the local community in Lakshadweep Islands since 2005. It is a great achievement for NIOT as the fresh water supply from the plant has significantly reduced the incidence of waterborne diseases like diarrhea and the prevalence of hypertension and renal diseases. Further, towards scaling up the technology for mainland requirements, NIOT also commissioned an experimental floating barge-mounted LTTD plant off the Chennai coast with a capacity of 1 million litres per day. NIOT has also successfully commissioned and has been operating the LTTD process at NCTPS, utilizing the huge amounts of warm water discharged continuously from the plant. Currently, efforts are on to transfer the technology to the industry for putting up such plants in islands and power plants. Design of a large capacity offshore desalination plant is also in progress. Wave energy. One form of renewable energy from the oceans is wave energy. A pilot plant based on the oscillating water column principle was commissioned at Vizhinjam in Kerala during 1991, successfully demonstrating that wave energy could be converted to electrical energy. The plant has been decommissioned after successful demonstration of the concept. NIOT is now working on a small floating wave-powered device called backward bent ducted buoy for remote locations. Other forms of ocean energy using currents and temperature difference are also being pursued. Deep sea technology and ocean mining. The deep ocean has abundant mineral resources like polymetallic nodules, cobalt-rich manganese crust, and hydrothermal deposits. The polymetallic nodules containing manganese, cobalt, nickel, and copper are viewed as potential resources to meet the increasing demand for these metals worldwide. India has a status of pioneer investor and has been allotted a site in the Central Indian Ocean Basin by the International Seabed Authority for exploration and technology development for polymetallic nodule mining. Deep Sea Technologies and Ocean Mining Group of NIOT has been actively involved in development of technology for polymetallic nodule mining from 6,000-meter water depth. As a first step towards development of underwater mining system for mining manganese nodules at 6,000-meter water depth, an underwater mining system operable at 500 meters water depth was developed. The underwater mining system is a crawler-based system which moves on the seabed under remote control from the mothership at top. The crawler has been designed to operate on the soft seabed and has special track belts with involute teeth to compact the bed during motion. Pumping operations were tested at 415-meter depth successfully. The crawler was subsequently augmented with nodule collector and crusher system, and its performance was demonstrated at 500 meters. Based on its performance, the system is being upgraded for 6,000-meter water depth for nodule mining. A soil tester capable of measuring soil properties in situ was developed and successfully tested at 5,000 meters water depth. The Coastal and Environmental Engineering Group focuses on the development of capacities and technical services for sustainable coastal infrastructure. The group specializes in handling projects for coastal investigations, hydrodynamic modeling, sedimentation studies, coastal observations. Presently, the Coastal and Environmental Engineering Group has been entrusted with projects such as Sustainable Shoreline Management, Technical Criteria Atlas, HF radars. Sustainable Shoreline Management aims at developing technologies for eco-friendly shore protection methods along with demonstration at select sites. Technical Criteria Atlas envisages developing an engineering design reference for environmental parameters like sediment transportation rate, current, tide, and waves. The atlas covers the entire coastline of India, including islands. The group is also responsible for providing studies and services in the areas of site investigation, planning, engineering design, environmental impact assessment for coastal development projects like harbour, power plant, etc. The resources include the latest equipments and laboratory facilities for bathymetry, geophysical, geological, geotechnical, environmental and oceanographic surveys. The group has undertaken a number of investigation projects all along the Indian coast since its inception. One such major project being implemented now is called Kalpasar project, which aims at construction of a dam across Gulf of Khambat in Gujarat. This project includes extensive field observations and numerical studies to prepare the detailed project report DPR. Coastal and Environmental Engineering Group installs and operates HF radar network along the Indian coast. This network is capable of providing continuous observations of ocean surface currents over an area of more than 10,000 square kilometers. The group thus strives to excel in the fields of coastal observation, engineering investigation, and engineering solution related to coastal space. Submersibles and Gas Hydrate Group of NIOT is involved in development of deep water systems in ocean exploration and harvesting deep water resources. A deep water remotely operable work-class submersible, ROSUB 6000, has been developed by NIOT. ROSUB 6000 comprises remotely operable vehicle, tether management system, launching and recovery system, high voltage, high frequency power conversion and transmission system, data telemetry and acquisition system, integrated navigation system, control and operational system, and scientific payloads. The submersible, rated for 6,000 meter depth of operation, is equipped with multifunctional tools and sensors for offshore applications such as seabed imaging, pipeline routing, wellhead detections, sampling, deep water exploration, etc. The first exploration sea trial was conducted during October 2009 in Krishna Godavari Basin at Gas Hydrate site in Bay of Bengal. First design depth qualification trial at Central Indian Ocean Basin was successfully conducted during March-April 2010 using ORV Sagar Nidhi by testing all the subsystems for its envisaged functionality at the maximum depth of 5,289 meters. Indian tricolour was dropped by NIOT at these depths, and India joined a select club of nations. NIOTians promise to take you to new depths every time. As a part of its quest for the alternative fuels and achieving energy security for the nation, Ministry of Earth Sciences has initiated a program for the exploration and study of the gas hydrates. Gas hydrates are crystalline forms of low molecular weight hydrocarbons which has attracted attention as a future potential energy resource. NIOT has been given the mandate to develop technological tools for the exploration of gas hydrates. One of them is a deep water autonomous coring system being developed by NIOT in partnership with Williamson & Associates, Seattle, USA. Operational trials of autonomous coring system are in progress in Indian seas. Ocean acoustics. Acoustics offers the most effective means of exploring the ocean and judging the underwater environment. The key to successful interpretation of sound in the ocean lies in research efforts that are both scientific and technology development oriented. Thus, part of the research concerns improving the fundamental understanding of underwater acoustic phenomena, while others focus on the development of measurement systems and techniques with which to test and apply our understanding. The group focuses on research, development and implementation, and interpretation in significant areas of underwater acoustics, wherein a few initiatives have been taken up in our country in the last 1 decade. Marine Sensor Systems was established in NIOT with a mandate to develop and demonstrate underwater sensors-based technologies for oceans. Needs of NIOT projects are unique, and to meet these requirements, specialized facilities are required. Many electronic support facilities like helium leak detector, climatic chamber, corrosion test facility, shock and vibration system have already been established, and more facilities are in the pipeline. NIOT has taken up the task of developing non-off-the-shelf underwater components and subsystems in association with Indian industries, 250 kilowatt underwater motor, single-mode fiber optic connector for deep water application, subsea power systems, to name a few. Underwater acoustic transducers form a vital element of most of the underwater instruments. NIOT has developed an expertise in design and development of acoustic transducers to suit various underwater applications. Marine sensors and systems based on the user needs are also being developed by Marine Sensor Systems. The group has many publications and also filed applications for patents for the products developed. The Ocean Electronics Group has been formed to focus on technology development in ocean observation and ocean systems. The group is currently concentrating on the development of deep ocean pressure recorders for tsunami warning systems, drifters and autonomous underwater sea gliders. The profiling drifters are fitted with CTD sensors that drift freely at 2000 meters water depth. They are then sent to the sea surface, collecting in situ water parameters and report to an orbiting satellite and descend again back to their parking depth for the next cycle of operation. The periodic profiles of the temperature and salinity would enable better understanding of the ocean circulation, enhance climate predictability and validation of satellite data. The group has developed a deep ocean pressure recorder system with new tsunami detection algorithm. The laboratory trials have been completed and the system is undergoing deep water trials. The group is also working on INSAT-based communication system for observation system. Marine biotechnology is one of the emerging tools to investigate the vast resources of marine flora and fauna in a sustainable manner. A number of technology development activities, including biochemical and biotechnological aspects, are being addressed for exploring and enhancing marine living resources through state-of-the-art laboratory and farm facility created at Chennai and at Andaman and Nicobar Islands. NIOT has successfully developed bubble column reactor, tubular photobioreactor and raceway systems for mass culture of marine microalgae in order to produce nutraceuticals such as lutein, phycocyanin and astaxanthin in pilot scale. Attempts are also being made to produce biofuel from marine microalgae. NIOT has also successfully collected and isolated microorganisms from endophytic communities, deep-sea water and sediment samples. So far, 55 bacterial and 20 fungal strains have been isolated and purified for testing against various human pathogenic microbes and biofouling organisms. Towards enhancement of marine living resources, the technology for open sea cage culture of marine fin fishes is being developed. Additionally, the Institute is engaged in design, fabrication and deployment of fish aggregating devices and artificial reef to support the livelihood security of the coastal communities in islands and mainland. The Ocean Observation System's erstwhile National Data Buoy program was established in 1996 with the prime objective to operate, maintain and develop moored buoy observational networks. Moored data buoys. The data buoys are offshore floating platforms fitted with meteorological and oceanographic sensors moored at specific locations to observe in situ met-ocean data at regular intervals. These buoys are powered by batteries and are equipped with GPS to provide the buoy location. Time series observations are vital to improve the understanding of ocean dynamics, variability, and are used to monitor the marine environment and to improve weather and ocean state forecast. The Omni buoys are moored buoy network in northern Indian Ocean and are more similar to data buoys but have the capability to measure ocean current, conductivity and temperature up to 500-meter depth and transmit hourly data through satellite. In addition, these buoys are also equipped with radiation sensors and rain gauges too. The tsunami buoys. As challenges arise in the form of natural disasters, OOS is now entrusted to deploy buoys capable of identifying tsunamis as part of Tsunami Early Warning System in India. OOS team has developed, tested and has established Tsunami Buoy System and BPRs in Indian seas. The tsunami buoy systems consist of two units, a surface buoy and the bottom pressure recorder BPR. Communication between BPR and the surface buoy is established through acoustic modems. The observed data from these moored data buoys and tsunami buoys are transmitted through satellite along with location information once in 3 hours to the state-of-the-art shore station facility at NIOT Chennai. The shore station is manned 24/7 and the data obtained from data buoys and tsunami buoys are disseminated in near real time to Indian National Centre for Ocean Information Services in Kois, Hyderabad for further processing. The program's achievement is only a step, though a substantial one, on its long march towards a societal cause. Vessel Management Cell manages the running, operation and maintenance of 5 vessels by outsourcing various services. Technical management and overall control, program planning and implementation is done in-house. Ministry of Earth Sciences acquired 2 coastal research vessels, Sagar Purvi and Sagar Paschimi, during 1996. To manage these 2 vessels, MOES established the Vessel Management Cell at NIOT. The vessel Sagar Paschimi was commissioned in November 1996 and Sagar Purvi in December 1996. The vessels have been specially designed for coastal oceanographic work. During 2006, VMC acquired new ocean research vessel Sagar Manjusha for deployment of data buoys and for other scientific activities of NIOT. ORV Sagar Nidhi joined NIOT fleet of vessels. This vessel is India's most sophisticated research vessel, specially built for technological demonstration in deep sea. The vessel is versatile ocean observing platform equipped with technologically advanced scientific equipments and related facilities. The vessel is fully automatic diesel-electric type equipped with azimuth thrusters, improving the behavior of the ship in rough seas. Sagar Sangamam Conference Centre is NIOT's commitment to provide a common platform for like-minded scientists and engineers to meet and freely exchange ideas and concepts that will benefit the world community. ATF, a state-of-the-art acoustic test facility, ATF, was set up at NIOT to cater to the needs of test and calibration of marine instruments. ATF is accredited by the National Accreditations Board for Testing and Calibration Laboratories, NABL, New Delhi. Hyperbaric Test Facility at NIOT is the first of its kind in India. Testing at this facility saves a lot of time and money for qualifying underwater components which otherwise would have been by actual testing in the sea at that depth. Hyperbaric Test Facility is used to simulate the pressure and deep sea environment inside a high-pressure vessel. The facility has been designed to test components at an external pressure up to 90 megapascals, which is approximately equal to 9,000 meters of water depth. NIOT Library is well equipped with modern facilities and resources to provide the research community with technical information needed to achieve its objective. Ocean, the inner space, holds the key for the human survival on planet Earth. Rapidly increasing needs of India, the nation on the move, can be met only when the resources from the oceans are sustainably harvested. NIOT, the modern mariners, strive to help the nation in achieving the security in water, food, energy, industry, coastal protection, climate change, capacity building and human resource development.